Good morning students. Today we are going to new problems in current electricity chapter only. Now this is one problem I am repeating here. A resistance of 10 ohms is connected to a cell of EMF having an internal resistance of 1 ohm. What should be the value of additional resistance to be connected in series so that the potential difference across 10 ohms may be 5 volts? This is the question. Once I am going for data. See, resistance how much is given? R is equal to 10 ohms is connected to a cell of EMF. EMF is equal to 6 volts is given. Having an internal resistance of small r is equal to 1 ohm is present. What should be the value of additional resistance to be connected in series? So RS value is equal to how much? So that potential across here 10 ohms may be 5 volts, means along 10 ohms resistor V is equal to 5 volts is given. So students, here we know V is equal to IR formula. V is equal to IR formula means this is 5. So here the thing is I into this is 10 is equal to 5. So I value is equal to 5 by 10, that is 1 by 2 or otherwise 0.5 amperes current we are finding. So for understanding purpose here, see students, I am drawing one diagram here. This is one battery having EMF E is equal to 6 volts. In this one, some internal resistance small r is equal to 1 ohm is present. Okay, here external resistance r is equal to 10 ohms is given. Additionally, here some RS is introduced. So we want to find out this RS value. So in this entire circuit, how much current we are observed here? I value is equal to 0.5 observed. By Kirchhoff's second law, we have here the notation is E is equal to I into small r plus capital R plus RS. So now E value is equal to 6. This is 0.5. So this one small r value is equal to 1. Here capital R is 10 is given. Now this is RS. So students, this one we can represent like this. 6 is equal to 1 by 2 into 11 plus RS. So now 12 on cross multiplication is equal to 11 plus RS. Therefore RS value is equal to how much? That is 12 minus 11, that is 1 ohm. So here resistance in series with 10 ohms is RS nothing but is 1 ohm. This is the answer for this question. Okay, this is the simple question for us. Okay students, right, then we will go for one more problem also. See students, this is one more question, just I am observing here. 24 cells, each of internal resistance 0.5 ohms and EMF 1.5 volts are used to send current through external circuit of 3 ohms resistance. The best method of grouping them is that person is expecting. See, once I am going for data first of all. So 24 cells means total number of cells. That is I am taken as 24. This value is equal to I am taken as m into n. So that is the total number of cells is present. Okay, m is number of rows. M is number of rows. We may guess n is number of cells in one row I am mentioning here. So this is the thing. So internal resistance how much is given? Small r is equal to here 0.5 ohm is given. EMF value is equal to 1.5 volt is given. So here external resistance R value is equal to 3 ohm is given. Okay, in best method of grouping that person is expecting. Best method of grouping means in best method maximum current is flowing. Okay, maximum current is present. See students, generally we have one formula. Okay, I in circuit or current in circuit is current in circuit that is in mixed grouping, I value is equal to mne divided by here m into capital R plus n into small r. This is the formula. So students, once observe carefully here, for maximum current, for maximum current we have one notation, that is mr value is equal to nr. So here m we don't know, here external resistance that is capital R value is equal to 3, so then this one n is nothing but this is 0.5. 0.5 is nothing but 1 by 2 also we will represent. Therefore we can get m by n value is equal to 1 by 6 we can get it. Okay, see students, let this one I am taken as equation 1, this is I am taken as equation 2. So how many equations we are observed? 2 equations we are observed. So 1 into 2 we are represented means mn into m by n is equal to 24 into 1 by 6. This is the thing. So students, here observe n and cancel, here m square value is equal to, this is how many times cancel? 4 times, m square value is equal to 4, implies m is equal to 2 we are getting. So we know the thing, therefore from 1 equation 1 mn is equal to, that is 24, m value is already 2, n value is equal to 24, therefore n is equal to, we are finding 12, therefore we are finding here m value is equal to 2 and n value is equal to 12. So nothing but 2 rows is present, in each row 12 cells are present, that is the thing. So here m value is equal to 2 and n value is equal to 12. This is the thing. So here which option is suitable? Here m value to n value is equal to 12 means this is in our given question, fourth option is suitable for us. So answer is fourth option. Okay students. So students, this is also one more simple problem for you, that is two cells of EMFs E1 and E2 and internal resistances R1 and R2 are connected in series with an internal resistance, okay, external resistance. First to help each other, so I am going here, first helping each other. So then one more thing is, in second case here both are opposing, both are opposing each other. So what is the difference between these two? Okay, both are, we will observe here. For example, this is one cell is present, this is a second cell is present here in series. Okay, so here this is the negative terminal of the first cell, this is connected to positive terminal of the second cell. But in second case this is the thing, but this one is observing like this. So here negative terminal of first cell is connected to negative terminal of the second cell. This is the things we may observe. Here this is E1 and this one is E2. Here this is E1, this one is E2. So here internal resistance R1, here internal resistance R2, here R1, here R2. So this is the thing we may observe. So see students, here we are introducing some external resistance, that is R. Here also I am introducing one more external resistance R. In this condition some I will be coming here, in this situation I will be coming here. So is it clear or not? Okay, or otherwise in between, for example here I am choosing this is A, B, and this one is I am taking A and B also. So just observe carefully students, here in this case E effective is equal to, I am taken as E1 plus E2. So here both are in a series combination without any disturbance, but here in series combination only, but both are opposing. So this one is I am taking E1 minus E2. So one thing here, the thing we may represent by Kirchhoff's second law, here I am taking as E effective or nothing but E1 plus E2 is equal to I into R1 plus R2 plus R. I am representing here, this is one more thing, e1 plus e2 or e1 minus e2 is equal to I into r1 plus r2 plus r. So one thing, observe students, here currents ratio is given. So this is first time in first case, here second time second case. So this is I1 I am representing, so this one is I2 I am taking like this. Is it clear or not? So then here in given question, given I1 divided by I2 is equal to given as, how much is given? 3 by 2 is given. So expecting E1 divided by E2 value is equal to how much? So once just by taking the ratios, therefore can we represent like this, E1 plus E2 by E1 minus E2 is equal to, here I1 into R1 plus R2 plus capital R, here I2 into R1 plus R2 plus capital R. So this one and this one just I am cancelled here. So we will get here E1 plus E2 divided by E1 minus E2 is equal to, here I1 by I2 ratio is how much is present? 3 by 2 is present. So on cross multiplications, 2 into E1 plus E2 is equal to 3 into E1 minus E2. So just on expanding, so 2E1 plus 2E2 is equal to 3E1 minus 3E2. So now students, here 3E1 minus 2E1, here 2E2 plus 3E2. So this is 5E2 is equal to, here E1. Now E1 divided by E2 values we can observe as 5 by 1. Therefore E1 by E2 values is equal to, we can get as 5:1. This is the relation, or this is the answer we can able to find. This is the very simple method we are observed. See students, this is very important model for you, and also in theory classes we are discussed about this same model. Just we will go through this conditions here. So how the condition is given here, once we will check it. In the given circuit, which is a part of a closed circuit, the currents I1 and I2 are respectively. We want to calculate here I1 is equal to how much and I2 is equal to how much. So let students, this is one junction we are observing. I am observing the junction as O, okay, named as O. At this junction some potential I am representing V naught. So students, once observe carefully here, I am imagine some current I is coming here. So now by Kirchhoff's first law, okay, or this is node rule, we have one thing, sum of incoming currents is equal to sum of outgoing currents. So at node O, sum of incoming currents is I is equal to, here I can represent I1 plus I2. So this is the thing we have. So students, observe carefully here, instead of I, by Ohm's law we can able to write like this as 30 minus V naught divided by 10. So and here instead of I1 I can represent like this as V naught minus 12 divided by 20 plus, and one more thing is here V naught minus 2 divided by 30. So this is the thing we may observe. See students, both sides just I am cancelling these zeros, this 0, this 0, this 0 I am cancelled. So now here 30 minus V naught is present here. Here LCM is 6. So this one 3 into V naught minus 12 plus 2 into V naught minus 2. So just expect mathematical students. Now this one is 6 into 30 minus V naught is equal to, this is 3 V naught minus 36 plus 2 V naught minus 4. So this is 180 minus 6 V naught is equal to 5 V naught minus 40 we are observed. So next in further step I am writing 180 minus 40 came this side means plus 40 is equal to 5 V naught minus 6 V naught came this side means plus 6 V naught. So students, this is 180 plus 40 is nothing but 220. 220 is equal to here 11 V naught we are observed. So therefore V naught value is equal to how much, students? V naught value is equal to 220 by 11. This one is equal to 20 volts. This is V naught value. So once observe, we want to find out I1 values and I2 values. So for I1, I am representing like this. I1 is nothing but what here? V naught minus 12 divided by 20. So I1 is equal to 20 minus 12 divided by 20. This is 8 by 20, nothing but 4 by 10. So I1 is equal to, we can get as a 0.4 amperes. Similarly, just go for I2. For I2 means, I2 is equal to, here how much we are represented? V naught minus 2 divided by 30 we are represented. So I2 is equal to 20 minus 2 by, here that one is 30. So this one is, we will represent here 18 by 30. 18 by 30 is nothing but here sixth table, or otherwise third table here, 6 divided by 10. So I2 value is equal to 0.6 ampere. So we are finding I1 as 0.4 amperes and I2 as 0.6 amperes. So these are the things we are calculated. Okay students, in next class remaining problems we will solve it on this same chapter. Okay, thank you.